Student, myself Veena, Assistant Professor, Government Science College, Bangalore. In this class, let us study about sin mx cos nx. That is reduction formula for sin mx, reduction formula of sin raised to mx cos raised to nx dx. With limits, without limits. We know that for any two numbers p and q, d by dx of cos px sin q raised to x is equal to, that is you have to differentiate. ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡುವಾಗ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಬೈ ಪಾರ್ಟ್ಸ್, ದಟ್ ಈಸ್ ಫಸ್ಟು ಕಾಸನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿ ಆಮೇಲೆ ಸೈನನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿ. ಕಾಸನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದರೆ ಏನು ಬರುತ್ತೆ, ದಟ್ ಈಸ್ p into cos raised to p minus 1x into differentiation of cos x is minus sin x. So put a minus sign here. So sin of q, already differentiation of cos x is sin, that is q plus 1x. Next differentiation of sin qx, that is q into sin raised to q minus 1x. Again differentiation of sin x is cos x, therefore it becomes cos raised to p plus 1x. Now it can be written as minus p cos raised to p minus 1x sin raised to q plus 1x plus q into sin raised to q minus 1x cos raised to p plus 1 can be written as cos raised to p minus 1x into cos square x. Now cos square x is nothing but 1 minus sin square x. So minus p cos raised to p minus 1x sin raised to q plus 1x plus q into sin raised to q minus 1x cos raised to p minus 1x cos square x can be written as 1 minus sin square x. Then remove the bracket and simplifying, minus p cos raised to p minus 1x sin raised to q plus 1x plus q into q sin raised to q minus 1 cos raised to p minus 1x multiply with 1 and then with minus sin square x. So it becomes q raised to sin raised to q minus 1x cos raised to p minus 1x plus it minus minus q sin raised to q minus 1x cos raised to p minus q minus 1 plus 2 sin square x is there into cos p minus 1x. Now sin raised to q minus 1 plus 2 is q plus 1. So sin raised to q plus 1 and cos raised to p minus 1. In these two, cos raised to p minus 1 and sin raised to q plus 1 is common. Therefore this is equal to, and minus sign common, that is remains p plus q cos raised to p minus 1x sin raised to q plus 1x plus, and this term q into sin raised to q minus 1x cos raised to p minus 1x. So now put p minus 1 is equal to n, so that n is p is equal to n plus 1 and q plus 1 is equal to m, so q is equal to m minus 1. Now substitute these values here, that is d by dx of cos raised to n plus 1x sin raised to m minus 1x is equal to p plus q. P is n plus 1, q is m minus 1, that is equal to nothing but n plus m cos raised to p minus 1, that is cos raised to nx, and sin raised to q plus 1, that is sin raised to mx. In place of q plus 1 put m, mx plus q is m minus 1 sin raised to q minus 1 is equal to, q minus 1 is nothing but m minus 2x cos raised to nx. So only cos raised to nx. Now integrating both sides with respect to x. Now differentiation, integration of differentiation is nothing but cos raised to n plus 1x sin raised to m minus 1x, that is we integrate both sides. So that is equal to integration of, that is minus of m plus n integration of cos raised to nx sin raised to mx plus m minus 1 integration of sin raised to m minus 2x cos raised to nx. Since it is an integration, we have to put dx. Okay. Now, but we want cos raised to nx sin raised to mx, integration of cos raised to nx sin raised to mx. Therefore, take to this side, integration of cos raised to nx sin raised to mx dx is equal to, now bring this to this side, left right side, that is minus cos raised to n plus 1x sin raised to m minus 1x, and if you bring this m plus 1 right hand side, it is divided by, that is 1 divided by m plus n, and the second term becomes m minus 1 divided by m plus n integration of sin raised to m minus 2x cos raised to nx dx. Now, this is the reduction formula for cos raised to nx sin raised to mx. Now, with limits. So, therefore 0 to pi by 2 sin raised to mx cos raised to nx dx is equal to, put the limits, that is minus 1 divided by m plus n integration from 0 to pi by 2 cos raised to n plus 1x. So, here there is no integration sign, therefore cos raised to nx sin raised to m minus 1x varies from 0 to pi by 2 plus m minus 1 divided by m plus n 0 to pi by 2 sin raised to m minus 2x cos raised to nx dx. Now, if you put upper limit pi by 2, cos of pi by 2 is 0, so whole value is, upper limit is 0. If you put 0, that is lower limit, sin of 0 is 0, therefore the whole value is 0, first term. Therefore, it is equal to 0 to pi by 2 sin raised to mx cos raised to nx dx is equal to m minus 1 divided by m plus n integration from 0 to pi by 2 sin raised to m minus 2x cos raised to nx dx. Now, it can be denoted as I of m comma n, that is equal to m minus 1 divided by m plus n I of m minus 2 comma n. Now, changing m to m minus 2, m minus 4, m minus 6 and etc. So, it becomes I of m minus 2 comma n is equal to m minus 3 divided by m plus n minus 2 I of m minus 4 comma n. Similarly, I of m minus 4 comma n is equal to m minus 5 divided by m plus n minus 4 I of m minus 6 comma n, and so on. So, the last term becomes I of 3 comma n, that is equal to 2 divided by 3 plus n I of 1 comma n if m is odd, and I of 2 comma n is equal to 1 divided by 2 plus n I naught comma n if m is even. Hence, I of m comma n is equal to m minus 1 divided by m plus n, m into m minus 3 divided by m plus n minus 2, m minus 5 divided by m plus n minus 4 up to 2 divided by 3 plus n if of I of 1 comma n if m is odd, or that is equal to m minus 1 divided by m plus n into m minus 3 divided by m plus n minus 2, m minus 5 divided by m plus n minus 4 and so on, divided by 1 divided by 2 plus n I naught comma n if m is even. Now, consider I of 1 comma n, that is equal to integration from 0 to pi by 2 cos raised to nx sin x dx. So, its integration is, since differentiation of cos x is sin x, its integration is equal to cos raised to n plus 1 x divided by n plus 1 varies from 0 to pi by 2. So differential of cos x is minus sin x, therefore it is equal to minus. Now cos of pi by 2 is 0, cos of 0 is 1, so lower limit is 1, therefore minus of minus becomes plus, that is equal to 1 divided by n plus 1. Similarly, I naught comma n is equal to 0 to pi by 2. So cos raised to nx dx, its value we already derived, that is n minus 1, n minus 3 divided by n minus 2 up to k, where k is equal to 1 if n is odd and k is equal to pi by 2 if n is even. Therefore, this reduction formula becomes I of m comma n is equal to m minus 1 divided by m plus n into m minus 3 divided by m plus n plus 2 and so on, divided by 2 divided by 3 plus n, 1 divided by n plus 1, where n may be odd or even. So if m is even and n is odd, then it is equal to I of m comma, that means if both m and n are even, then its value is equal to m minus 1 divided by m plus n into m minus 3 divided by m plus n plus 2, n minus 2, here also it is minus 2, into m minus 5 divided by m plus n minus 4 and so on, and n minus, similarly this is equal to n minus 1 divided by n, n minus 3 divided by n minus 2 and so on. So into pi by 2 if both m and n are even, if it is equal to 1 if both m and n are odd, that is I of m comma n is equal to m minus 1 divided by m plus n, m minus 3 divided by m plus n minus 2 and so on. Similarly, n minus 1 divided by m plus n minus 4 and so on, n minus 3. In upper part it is m minus 1, m minus 3, m minus 4 and so on, n minus 1, n minus 3, n minus 4 into k. K is equal to pi by 2 if both m and n are even. In all other cases k is equal to 1. This is the reduction formula with limits. Let us solve some more problems in the next class. Thank you.